Welcome to all.
Good morning, this is Judy from the Association of Lifelong Learners, and I'm here with Andrea Miehls from the Hammond Bay Biological Station, and she's here to talk to us about vampires of the Great Lakes. So I'm going to go ahead and let her take over. Go ahead.
All right, thank you, Judy, and thanks everyone for this opportunity to present today about sea lamprey. So yes, I'll be talking about the vampires of the Great Lakes. So we do have vampires swimming out in all of the Great Lakes, but they are fish vampires, not the regular vampire that you typically hear about. So they are sea lamprey, which are an invasive species from the Atlantic Ocean. So today we'll be taking a deep dive into this invasive species, learning about how they invaded the Great Lakes, why they have been one of the most destructive invasive species to have ever entered the Great Lakes. But the good news is that they are the best controlled invasive species in the Great Lakes, and in fact, one of the best controlled invasive species anywhere in the world. And it actually all began in northeastern Michigan at Hammond Bay Biological Station. At least the control program began, research on control began at Hammond Bay Biological Station in northeastern Michigan. And that is where I work, although today this is not my office at work, this is my office at home due to the pandemic. Hammond Bay Biological Station is a wonderful place to work. It is a field station of the US Geological Survey. Most of the funding for the work that occurs there comes from the Great Lakes Fishery Commission. And so that is what my shirt says today. And you can also see the logo on my presentation as well for the Great Lakes Fishery Commission. So that is who I work for. And yeah, I'm really happy to be talking about sea lamprey. So let's get started. You can see the picture here of a sea lamprey and its mouth. So sea lamprey are, like I mentioned, they are vampires. And the reason we call them vampires is because they suck the blood of other fish. So sea lamprey are a fish themselves, but they're a very unusual fish that's actually a parasite of other fish species. And you can see here the mouth of a sea lamprey is really its business end. That mouth has almost 150 teeth. Those teeth are all razor sharp, and they use those teeth, most of them, to suck onto the side of a fish. And most of the teeth that are surrounding the rim or the outside of the sea lamprey's mouth are used for grip. If you look closely at the center of the mouth, that is the sea lamprey's tongue. And the tongue is the truly nasty part, because what the sea lamprey do is they take that tongue and they'll piston it out. They'll lash it back and forth, and that is how they rip a hole in the side of the fish they've attached to. And eventually the blood and other bodily fluids come out of that hole. And that is what the sea lamprey will feed on for about a year to a year and a half of its life. And so that is how sea lamprey have become known as the vampires of the Great Lakes, and why they're such a horrible invasive species. This is what it looks like when a sea lamprey has attached to the side of a fish. It would be like something the size of a baseball bat attaching to us and drinking our blood and bodily fluids. I can tell you, none of us would have a very good day if that happened to us. And to the fish that a sea lamprey attaches to, it's almost certainly a death sentence. If 7 fish are attacked by a sea lamprey, in some circumstances, only one of those fish would survive. So on the flip side, 6 out of every 7 fish attacked by a sea lamprey could die. It adds up to about up to 40 pounds of fish that a single sea lamprey might kill during its lifetime. And before sea lamprey were controlled in the Great Lakes, there were about 2.5 million sea lampreys swimming in the Great Lakes feeding on fish. With each one of those sea lamprey killing up to 40 pounds of fish, that's 100 million pounds of fish that were dying every single year due to sea lamprey invading the Great Lakes. It was a complete catastrophe for the fishing industry, both commercial and recreational fishing industries within the Great Lakes when the sea lamprey invaded. Many of the fish that a sea lamprey attaches to will die directly due to blood loss. Those fish that are able to survive the sea lamprey attaching to them may still end up dying after the sea lamprey detaches, because of what you can see here in this picture. The sea lamprey leaves a pretty nasty wound. And for those fish, you know, there's nobody there out in the Great Lakes to clean that wound with soap and water and put on a Band-Aid. That wound will remain open and exposed to any of the pathogens, any of the bacteria that are in the water. And quite frequently, those wounds will get infected and the fish will die from infection. So sea lamprey result in the death of many, many fish in the Great Lakes in a few different ways. It's not just directly due to blood loss. So this is the invasion timeline for sea lamprey. As I mentioned earlier, sea lamprey are native to the Atlantic Ocean. And something that might be surprising to a lot of people is that sea lamprey are not considered harmful in the Atlantic Ocean where they are native. They are an appropriately sized parasite in the Atlantic Ocean relative to the fish that they feed on. In the oceans, sea lamprey will parasitize fish like sharks, tuna, swordfish, dolphinfish, or mahi-mahi. These are all very large fish. And relative to the size of that sea lamprey, which is considerably smaller, the sea lamprey is not a big energy drain. Yes, the sea lamprey still negatively affect those fish because the sea lamprey are drawing blood, but it's not so much that the fish host typically dies. So most of the fish hosts in the Atlantic Ocean actually survive a sea lamprey attaching to them, whereas in the Great Lakes, the fish there are just so much smaller relative to what's in the ocean, and those sea lamprey are so large compared to the size of the fish they attach to in the Great Lakes. Many of the Great Lakes fish succumb to the sea lamprey attachment. So that is why sea lamprey are considered a problem in the Great Lakes, but not considered a problem out in the oceans. And it turns out sea lamprey and their ancestors had been living in the ocean for millions of years. In fact, the lamprey lineage dates back over 360 million years. Sea lamprey and their ancestors that form the broader lamprey lineage are actually considered some of the oldest living vertebrates on Earth. The only other older living vertebrate is a hagfish. And we call these fish vertebrates, but technically lampreys are not actually true vertebrates either. They don't have a true backbone, although they do have a notochord, which is like a bundle of nerve fibers that runs down the length of their body, which allows them to be lumped in with the vertebrate category, though they are not true vertebrates. A few other fun facts, or funny or freaky facts about sea lamprey, depending on your perspective. Sea lamprey are jawless fish. I'll pull up my model if you can see my thumbnail here with me holding the model. So sea lamprey are jawless. They don't have jaws like other fish do, so they don't chomp anything. Instead, they suction. Sea lamprey also do not have a bony skeleton. Their skeleton is cartilaginous, just like the skeleton of sharks. At the end of my presentation, I'll pull out a live sea lamprey. So I will show everyone the live sea lamprey then, and we'll go over a few more details of their anatomy at that point. So back to the invasion timeline. Again, sea lamprey were living in the Atlantic Ocean for millions of years. It wasn't until the 1800s when humans began changing the landscape that sea lamprey were eventually allowed into the Great Lakes. What happened is that it was the era of canal building. During the 1800s and early 1900s, humans started digging out shipping canals to connect major bodies of water. And at the time, these shipping canals were a boon for economies. They allowed things like ocean-going vessels to eventually reach the Great Lakes. Some of the main canals that were built during that time were the Erie Canal and then later the Welland Canal. And it's those two canals that allowed sea lamprey into the Great Lakes. So this was all an accidental introduction. No one purposefully introduced sea lamprey to the Great Lakes. Instead, humans built the canals. And once those canals or once those corridors were opened, sea lamprey simply took advantage of them and swam into the Great Lakes on their own. So it was the Erie Canal, like I mentioned, that allowed sea lamprey to invade first Lake Ontario, and that was by the 1860s. And then sea lamprey were stuck there for decades until the Welland Canal was built. And it's after the Welland Canal was widened and deepened in 1919 that created a much better flow within the Welland Canal. And sea lamprey were drawn to that flow. And so they swam through the Welland Canal, which meant they exited Lake Ontario and swam into Lake Erie. And they were first found in Lake Erie by 1921. And then it was a straight shot for those sea lamprey to swim into the remaining Great Lakes. And so by the late 1930s, sea lamprey were found in Lake Superior. So Lake Superior was the last lake that sea lamprey had invaded. It also has the designation as being the first lake where sea lamprey control was put into place. And I'll talk more about that in a moment. For anyone that's pretty attentive to detail, they might notice that the date of invasion in Lake Michigan, 1936, is before the date of invasion in Lake Huron, which is 1937. The reason for that is that we don't actually think sea lamprey invaded Lake Michigan first. Instead, what these dates represent are the dates that sea lamprey were first found in these lakes. The way a sea lamprey is found is typically by someone fishing in a lake and catching a fish with a sea lamprey attached. The fishing pressure, commercial and recreational, has been for a long time much greater in Lake Michigan than Lake Huron. So it simply means that the odds of finding a sea lamprey in Lake Michigan were greater than in Lake Huron. So very likely the sea lamprey were in Lake Huron first. Nobody saw them though until 1937. When sea lamprey invaded the Great Lakes, it truly was devastating to the region. It was devastating to the economy as well as the way of life. At that time, the fishing industry was a major component of the economies within the Great Lakes region. And it actually still continues to be a major component of the economies in the Great Lakes region. But back when sea lamprey were first invading, these fishing economies were incredibly important. As sea lamprey invaded, they began taking out some of the most important fishery species. Lake trout, which is one of the dominant fishery species in the Great Lakes, were the prey that sea lamprey most preferred. Sea lamprey led to the extirpation, so the removal of lake trout from 4 out of the 5 Great Lakes. Now, it wasn't sea lamprey invasion alone that led to that extirpation of lake trout. Lake trout were also being heavily fished at the time, and so lake trout populations were already declining due to fishing. However, folks have looked back at the population trajectories of those lake trout, and whereas you see a declining population from fishing pressure, when sea lamprey invaded, suddenly those lake trout populations plummeted, and they plummeted to 0, to 4 out of the 5 Great Lakes. And again, the only lake that lake trout survived in was Lake Superior, because it was the last lake that sea lamprey invaded, and it was the first lake where the sea lamprey control program was implemented. So imagine this situation, what it must have been like for anybody living in the Great Lakes as these sea lamprey were invading. People have described it as watching a storm approaching over the horizon. You know, you can see the dark clouds looming. You can see a possibly horrible situation coming your way, but they were completely powerless to stop it. And so these stories are really quite moving that we hear from people that lived in the Great Lakes at the time. One of the unusual consequences of, or unexpected consequences of the sea lamprey invasion was the later population explosions of a second invasive species called alewife. So alewife are a type of fish. They're another invasive fish species from the Atlantic Ocean. They don't grow very large. I have a fishing lure here that's meant to represent an alewife. It gives you the impression, though, that, or it gives a good feel for the size of an alewife, as well as the fact that this is a fishing lure, so it tells you it's something that other fish might want to eat. So alewife are considered a bait fish or a prey fish. Prey fish would be the better word in the Great Lakes. Lake trout, when they were still abundant in the Great Lakes, were basically gobbling up all of the alewife as the alewife were swimming in from the Atlantic Ocean. But once sea lamprey decimated the populations of lake trout, suddenly there was no natural control, no natural predation on the alewife that were invading from the Atlantic Ocean. And eventually the alewife gained a foothold in the Great Lakes and their populations just exploded. For anyone that's watching that was alive during the 1960s, you might even have seen shorelines that along the Great Lakes that were filled with rotting carcasses of fish. Those were all the alewife that were in the Great Lakes at the time. What happened with the alewife populations is during a couple of warm summers in the 1960s, the water warmed up so much that it actually surpassed the thermal maximum for, well, basically the temperature that alewife can tolerate in the Great Lakes. And the alewife started dying off in droves and washing up on shorelines. And at the time, heavy machinery, like you can see in the picture here, was needed to actually shovel the dead alewife carcasses from the beach into trenches to try and contain the mess. So imagine what this must have been like. Who would want to spend their Saturday afternoon recreating along a Great Lake when there are thousands of rotting alewife carcasses right alongside you, right? Nobody's probably going to choose to spend their time on the Great Lakes then. So sea lamprey invasion, so bringing this back to sea lamprey, it affected the economy in multiple ways, directly through the fishing industry, but indirectly through a decline in the tourism industry as well, once these alewives started washing up on the shores and rotting there. So there were multiple ways that sea lamprey affected the economies and really caused a pretty horrifyingly bad situation in the Great Lakes at the time. Now, that's all the bad news about sea lamprey. The good news that I mentioned earlier is that sea lamprey populations are under control in the Great Lakes. And in fact, like I said, it's one of the best control programs in the world. Their populations have been reduced by 90% across the entire Great Lakes. So 9 out of every 10 sea lamprey in the Great Lakes is being removed through the control program, which is coordinated by the Great Lakes Fishery Commission. The Great Lakes Fishery Commission is a binational organization. It covers both Canada as well as the United States. And both of those countries partner together on the control program for sea lamprey. Now, the very first thing that was done, starting back in the 1940s and early 1950s, was to learn about the life cycle of sea lamprey. That was really the foundation for the control program that was eventually built. The idea here is you need to know your enemy, right? If any of you have ever played competitive sports, you know that if you're going up against an opponent, you need to learn something about that opponent, or at least it helps to know something about that opponent so you know what that opponent's vulnerabilities would be. Same thing for sea lamprey. Biologists first started studying the life cycle of sea lamprey so they could learn how those sea lampreys were vulnerable and how then they could exploit those vulnerabilities for control. So what we'll do now to introduce the methods that we currently use to control sea lamprey is we will walk through the life cycle of sea lamprey. We will start with the stage that's labeled number 1 on this diagram here, and that's the spawning adult stage. That is happening just about to happen right now in the Great Lakes. In our area of the Great Lakes, sea lamprey are currently undergoing their spawning migrations. They're moving upstream in Great Lakes tributaries looking for spawning habitat. Within probably the next couple of weeks, they will begin spawning in northeastern Michigan along the Lake Huron shoreline, as well as other places at about our same latitude in the Great Lakes. So those sea lamprey, like I mentioned, they have their annual spawning runs. The males head into the streams first. The females then follow. They find each other in the streams. The males and females pair up. Sometimes you might have multiple females on the same nest with a male, or maybe multiple males on the same nest with a female. But sometimes it's just a single male and a single female. They meet up in the stream, and then they begin moving rocks in the stream to build their nests. And if you look closely at this picture, you can see what those sea lamprey are actually doing to move the rocks. They don't have hands to move the rocks around. Instead, they'll take their mouth that they had been using to suction onto the side of the fish, and now they'll suction onto a rock, and they'll move that rock to the spot in the stream that's a good spot for a nest, and eventually they will make their nest in the shape of a horseshoe. Once the nests are built, the males and females will spawn with each other. The males entwine their bodies around the females, which encourages females to release their eggs, and then the males will fertilize those eggs. Once spawning is complete, the adults will die. So the sea lamprey only have one opportunity to spawn during their lives, and that is it. And as a consequence, the females produce a whole lot of eggs. They only have one shot at spawning, so they give it their most. If you can see the thumbnail here where I am, my video is, what I'm holding is a jar of eggs from a single female sea lamprey. One female can lay up to 60,000 to 100,000 eggs. A particularly large female might even lay more than that. So it's a lot of eggs to come from just one spawning of a single male and single female sea lamprey in the Great Lakes. Now we know not all of those eggs will survive. We think it's about 10% across the board, with higher survival of those eggs in areas where we have the most pristine rivers, which would actually be where we live in northeastern Michigan. We actually have higher survival of those eggs than we do elsewhere in the Great Lakes because of the high quality streams that we have here, which equates to high quality spawning habitat for those sea lamprey. But even if only 10% of those eggs survive, that's still 6,000 to 10,000 sea lamprey that can result, young sea lamprey that can result from every male and female sea lamprey that mates in the Great Lakes. That's one of the reasons sea lamprey have been such a difficult invasive species, or a detrimental invasive species. It really only takes the mating of a couple of pairs of sea lamprey to completely populate an area with offspring. So again, like I mentioned, after mating, the adults die, but those 6,000 to 10,000 or more sea lamprey eggs live on. In a few weeks, those eggs will hatch. And what pops out is a large number of teeny tiny little larval sea lamprey. So I'm holding up another jar to the camera here in the thumbnail where my video is. When the sea lamprey pop out of the eggs, they're no larger than those eggs that they were in. They're all about the size of the tip of a pencil. After a few months, they'll reach the size of about the size of a grain of rice, or maybe some people have referred to these as looking like shredded cheese. There was once a first grader who said that the young sea lamprey looked like the sprinkles on her cupcake. So it gives you a whole new way of looking at that wonderful kid treat when you imagine 100 little sea lamprey larvae sprinkled on top. But at this stage, these larvae are actually rather harmless. So as larvae, the sea lamprey do not have fins, they do not have eyes, and most importantly, they don't have that parasitic mouth that they have as during their parasitic and their adult stage. Instead, they have an opening that's called an oral hood. What that oral hood does is it allows those sea lamprey larvae to draw water in, and then the larvae filter out the microorganisms living in the water, the zooplankton, the phytoplankton, and the bacteria and other microorganisms. And that is what those larvae feed on for the first roughly 5 or so years of their life. Though that larval stage does have a lot of variation. In streams that are warm, the larval stage may only last about 3 years, whereas in streams that are cold with poor nutrient availability and poor prey availability, that larval stage could actually last 10 or more years. But on average, it's about 4 to 6 years. For the larval stage is about 4 to 6 years in the Great Lakes. Now, what I haven't mentioned yet is where those larvae are living. Those larvae are still living in the streams that they were born in. Once they're large enough, they actually burrow into the bottom of the stream, and that is where they'll stay for much of their time. These burrows are quite helpful because they provide good protection from predators. Those sea lamprey larvae are also typically brown, which allows them to camouflage into the bottom of the stream bed, which is typically brown as well. And they're mostly only active at night. And it's through those 3 ways that sea lamprey can avoid most predation. After that 4 to 6 years, the sea lamprey larvae will grow to about the size of a green bean. And that's what I'm holding in the jar here over in my video thumbnail. So certainly not very fast growth, but it's enough for them to finally reach a size where they are able to go through a metamorphosis to become a parasite. So sea lamprey have a true metamorphosis, just like Butterflies go from caterpillars into beautiful butterflies, and tadpoles turn into frogs with a metamorphosis. Sea lamprey turn from a harmless filter feeding larvae into a parasite. And it's during that metamorphosis that the sea lamprey finally gain their fins, their eyes, and finally that parasitic mouth with all of the teeth. Going back now to the thumbnail of where my video feed is, I am holding a newly metamorphosed parasitic sea lamprey in the jar here. This sea lamprey is only about 5 inches long. It's a little bit tricky to see over the camera right now, but it basically looks identical to an adult sea lamprey, just in miniature size. I've had some people actually tell me that this size sea lamprey is cute. And while perhaps it is cute because it's in miniature form, it is a cold-blooded killer. Cold-blooded because, of course, sea lamprey are a type of fish, and killer because even at this stage, that sea lamprey is capable of attaching to a fish, drinking the blood, and killing that fish. So it's after the metamorphosis that the real nightmare begins for sea lamprey in the Great Lakes. At this stage, the sea lamprey will now leave the streams that they were born in. They will move out into the Great Lakes in search of fish to feed on. And as I mentioned earlier, they'll only feed on fish for about 12 to 18 months, or a year to a year and a half. But during that time, they will kill up to 40 pounds of fish. They are quite destructive during that short amount of time. Once they have fed on fish for that long, they will grow rather quickly. And in that 18 months or so, they will reach the size of the full-grown adult that I am holding here. The average adult sea lamprey is about 18 inches long, although it's very variable from about 16 to 24 inches, and we even see a few larger and smaller than that. Average length, though, is about 18 inches, like the model that I'm holding. Once they reach that full-grown size, they will no longer feed on fish. They'll drop off of the sides of fish, and then they will move into a stream to spawn. Now, it turns out that sea lamprey are choosy when it comes time to pick a stream to spawn in. Unlike salmon, which many people might be familiar with salmon returning to the streams that they were born in, sea lamprey actually don't do that. They don't have the luxury of doing that. Unlike a salmon, which is large and strong and a good and fast swimmer, sea lampreys are smaller and thinner. They're efficient swimmers, but they're not particularly strong or fast swimmers. So instead of being able to swim all the way back to the stream they were born in, which could be 100 miles away or even more if the sea lamprey attached to a fish that was undergoing a migration. So instead of going back to where those sea lamprey were born, they instead pick out a stream that's close to where they are. And the way they pick out a stream is they actually sniff the streams. It might be a little surprising to hear this, but sea lamprey have a very good sense of smell. They have a single nasal organ on their head, or a single nostril on their head. It's the little dot that you can see here in my camera thumbnail. That dot leads to, or that nostril leads to a nasal organ that's about 2 to 3 times the size of their brain. So these really are smelling creatures. They're not thinking creatures, they're smelling creatures. Sea lamprey make a lot of decisions in their life based on what they can smell. They're like swimming noses out in the Great Lakes. So when they come to a potential stream for spawning, they'll actually sniff that stream. And what they're sniffing for is the presence of larval sea lamprey, because if they can smell healthy larval sea lamprey in that stream, that means it's a good habitat for their own larvae to survive. And the females will also be sniffing for the scents of males. Males will also sniff for the scents of other males as well, because if they can smell adult male sea lamprey in that stream, that means that the spawning season has begun. So there'll be plenty of opportunities for finding mates. So if the sea lampreys can smell those cues when they're at the mouth of a river, they will enter that river, head upstream, eventually finding a mate. They'll build the nest, the young will be produced, and the cycle repeats itself. And so remember, this conversation about the life cycle all started with trying to better understand the sea lamprey's vulnerabilities. And very quickly in the research program for sea lamprey in the 1940s and 1950s, those biologists realized that there were a couple of key life stages that could possibly be exploited for control. The life stages they identified were the ones that were in rivers. And the reason is that it's a whole lot easier to go out to a stream that's possibly right out your back door and find sea lamprey that they can remove or kill versus trying to ever control the sea lamprey life stage, that parasitic stage that's out in a Great Lake. Imagine how vast the Great Lakes are. It would be very difficult to ever try to find and control the parasitic stage because of the size of the Great Lakes. It's a lot easier to try and catch a sea lamprey when they're in a stream where they are concentrated. Currently, our control program focuses primarily on the larval life stage as well as the adult life stage. There's growing interest in trying to control that out-migrating, newly metamorphosed parasitic sea lamprey stage as well. But currently, it's the larval stage and the adult stage where we're attempting most of our control. And we'll talk about that now. The way that we control the larval sea lamprey, and it's the primary way that we control sea lamprey populations in the Great Lakes, is through the application of lampricides. Lampricides are a type of pesticide, but we call them a lampricide specifically because they are highly selective to killing lamprey without being harmful to other fish and organisms in the stream, or at least they have very minimal effects on other fish and organisms. This is what the lampricides look like. They are a yellow chemical compound that you can see with what I'm holding in my hand right now, as well as in the picture here. They're applied to hundreds of streams throughout the Great Lakes. These lampricides are highly effective and highly lethal to the sea lamprey living in the stream. And that is how that is a primary way we have been able to reduce sea lamprey populations by 90% throughout the Great Lakes. Now, I do feel like when I say things like these lampricides are highly selective to sea lamprey, I like to be able to back that up with a little bit of data and a little bit of reasons as the history of how these lampricides were discovered. The work on testing chemicals that eventually led to the development of our lampricides occurred at Hammond Bay Biological Station in the 1950s. Those researchers then tested over 6,500 different chemical compounds. Many of those were tested at multiple concentrations. So that's, it was upwards of 20,000 different tests that were run to discover eventually 2 lampricides, 2 chemicals at very specific concentrations that were lethal to sea lamprey, but not harmful to other fish and wildlife in the Great Lakes. And it was an incredible endeavor. The stories that we have heard from the folks that did this early work, they said to them it was like a calling, it was a mission. They knew they had the future of the Great Lakes riding on their shoulders when they were doing this work. So they worked day and night, weekends, as hard as they possibly could. And eventually they identified these 2 lampricides that have really been the savior of our fisheries in the Great Lakes and have allowed us to maintain our way of life within the Great Lakes region. So it's, arguably one of the most important discoveries for the Great Lakes in the last 100 years has been the discovery of these lampricides. And it's such a great story because it started in northeastern Michigan. So it's something we can all be proud of living in this area. The other way that helps control sea lamprey in the Great Lakes would be barriers. These barriers block the migration of spawning adults into streams. So there are hundreds of barriers throughout the Great Lakes. Some of them were barriers that were purposefully built to block spawning adult sea lampreys. Those barriers look like the bigger picture here that I'm showing. They are low head barriers. They are just high enough to block the sea lamprey from migrating upstream. But some fish, like the salmon that are capable of jumping, are still able to make it over these barriers and continue their migrations upstream. The control program also takes advantage of many pre-existing barriers. If you look at the smaller picture here, this is a barrier on the Sheboygan River. I believe the history of this barrier actually had to do with the lumber industry. So it's an existing barrier that's a fantastic barrier that blocks sea lamprey. So we take advantage of that barrier as well for our sea lamprey control program. So what's great about these barriers is that they deny access to possibly hundreds of miles of spawning habitat upstream of those barriers. And the other thing that the barriers do is they concentrate the spawning that eventually does occur between the barrier and the lake. Those adult sea lamprey are not going to give up on spawning. They will still spawn, but it's just happening now in an area that's small enough where logistically we can get people out and treat that region of the stream with lampricides. So barriers and lampricides actually work hand in hand for controlling sea lamprey. And these barriers are critical to our program. Now, the Great Lakes Fishery Commission and its partners are actually doing a lot of really good work right now on designing more modern barriers that still block sea lamprey, but are better at passing other fish species beyond just the jumping ones like salmon. So there's a lot of cool work right now to improve connectance of rivers for spawning fish populations while still blocking sea lampreys. It is critical that we block those sea lampreys in streams. So any barriers or any methods that might be used to improve river connectance we still have to ensure they are capable of blocking sea lampreys from reaching upstream spawning habitat. And a third method that is in development right now is trapping. So on many streams throughout the Great Lakes, we have traps that are there to collect the adult sea lamprey. So we attempt to remove the adult sea lamprey before they ever have a chance to spawn. Our researchers are still developing ways to collect a high enough population or a high enough number of the adult sea lamprey in streams to really have an impact on the overall populations of sea lamprey in the Great Lakes. They're working with all sorts of creative methods to lure sea lamprey into traps, which I'll talk about in a moment. But for right now, the one key feature of these traps for our control program is that they actually allow us to obtain population estimates for sea lampreys. I won't go into the details of how that is done, but essentially the trapped sea lampreys are used to eventually create a population estimate. So we have a handle on how effective our control program actually is. And our traps themselves, they're essentially large metal cages, a couple feet wide, tall, and deep. Many of them have an entrance on them that looks a bit like what I'm holding up in my video right now. The sea lamprey are able to swim through the opening. They push back these fingers on the trap. Once they're all the way through, these fingers come closed, and for the most part, they do a good job of keeping the sea lamprey in the trap. The other useful thing about traps for us is that the traps allow us to collect those adult sea lamprey, and then we use those sea lamprey that are collected both for research as well as outreach. Researchers at Hammond Bay Biological Station and elsewhere are using those live adults that are collected to develop additional ways to try to control sea lamprey populations. And I also use some of those, like my colleagues and I also use some of those sea lampreys for outreach as well. And you will see some of those sea lampreys in just a few minutes that I have here with me today. I mentioned just a few moments ago that researchers are trying to develop ways to lure sea lamprey into traps. And I also mentioned that sea lamprey have a very good sense of smell. And so researchers are trying to exploit that sense of smell by baiting traps with the scents that sea lamprey are attracted to. Most of the work so far has been focused on using the scents that mating male sea lampreys release in order to lure those lampreys into the traps. I mentioned just briefly that it's not just the female sea lampreys that are attracted to the scent of mating males. Male sea lampreys are also attracted to the scent of other mating male sea lamprey because it's a signal that spawning is happening. So if one male can smell another male in the stream, that means the party's on. They know the females will be there and lots of opportunities for mates. And so some of our traps have been baited with the scents that mating male sea lampreys release. You can see an example here. The gentleman in the lower right of the photo is holding up a vial of sea lamprey pheromone. And then in the larger picture, you can see a white tube in the upper left-hand corner. This tube is emitting the mating male pheromone. And this is a female sea lamprey that has smelled that mating male pheromone in the water. And from a distance of at least a half a mile, I believe, downstream is where this sea lamprey was released. It swam upstream right to the source of where that pheromone was being released. So that's the use, that's one way that attractant pheromones can be useful to, potentially useful to the control program. On the flip side, we also have researchers studying repellent pheromones. One of the ones that's being worked on is an alarm cue. I'm not going to attempt to show a video right now over Zoom because it probably wouldn't work well, but watching the alarm cue at work is pretty fascinating. The alarm cue basically is the scent that dead or injured sea lamprey would release. And when one sea lamprey smells this scent in the river, when one sea lamprey can smell a dead or injured sea lamprey in the river, that's a sign that something has gone wrong, and the sea lamprey's genes will tell it to move away from that area. Now, in a natural stream, the type of work that's being done right now is applying these alarm cues to areas at a low enough concentration that the sea lampreys can detect them, but then they will detect them and move away from the area that smells like death or smells like injured sea lamprey. A demonstration that we sometimes do at our lab is inundating a tank of live sea lamprey with these alarm cues, and then you see a completely different reaction. And that's what's shown here in the thumbnails of the two video clips. When you inundate a tank of sea lamprey with this alarm cue, to them, they're overwhelmed with the smell of death, and they swim as fast as they can to get out of that smell. And what it leads to is the water looking like it's boiling, at times sea lamprey jumping clean out of the water, like you can see in the thumbnail on the left. Now that is a response that they only do in tanks. It's not one that they would do out in the river, at least not using the concentrations that the alarm cues are used for research, but it's a pretty exciting response to watch nonetheless. And you can see the two links here below. If you'd like to pull up videos, they are available on YouTube. You can also just Google sea lamprey alarm response, and you should be able to find videos as well. Now, one way that we can use this knowledge of sea lamprey responses to attractant pheromones as well as repellent pheromones is in the context of push-pull sea lamprey control. Here's one way that it could work. There's a variety of ways. Here's one. Imagine a river that forks, and on the left side, we have a sea lamprey swimming upstream, and it comes to this fork. If we were to apply the repellent scent, the alarm cue, on one fork and apply the mating male pheromone scent on the other fork, which way do you think that sea lamprey will choose to go? Well, it's kind of a no-brainer. That sea lamprey is going to head into the fork that smells like love and mating, and they're going to avoid that fork that smells like death. And so by applying repellent pheromones as well as attractant pheromones in combination, we can essentially herd sea lampreys around in streams, pushing them into an area of the stream where we can either trap those adults readily, or perhaps it's an area of the stream where the habitat is poor and their larvae are unlikely to survive, or maybe it's an area that's just simply very easy to treat with lampricides. Either way, by applying the pheromones, the repellent and attractant pheromones in combination, we could help the efficiency with which our control program is conducted. And a final research method that's just in development, that's being tested this summer, is the application of pheromone antagonists. So far, what I'm talking about has been scents that the sea lamprey can smell and respond to. But something else that can be done is cutting off the sense of smell entirely for those sea lamprey. And that's what these antagonists do. They're like natural nose plugs that eliminate the sea lamprey's sense of smell. And so researchers right now are running experiments with applying these antagonists to the river, and they are seeing if they can cut off the sea lamprey's sense of smell, whether those sea lamprey are still able to find potential mates and then eventually spawn in tributaries. And that work is still going on, and we're really excited to see what those results look like. Okay, and as I begin to wrap up my presentation, I just have a little bit more information to convey. I was asked when I was asked to give this presentation, it was requested that I provide a bit of information about current populations. So what you can see here is the actual data behind sea lamprey populations in the Great Lakes. You can see one line for each one of the Great Lakes: Superior, Michigan, Huron, Erie, and Ontario. And on the x-axis, we have year since invasion. There's the historical abundance of sea lamprey on the far left side of the x-axis. And then I have more recent years shown on the x-axis. And so what you can see is if you look right here along the y-axis where we have adult sea lamprey abundance, you can see how high the historical abundances were. Once the control program was implemented, those abundances plummeted due to control. And now we have population sizes in the Great Lakes that bounce around at about 10% of their historic highs. So on the flip side, again, we have reduced sea lamprey populations by about 90%. Here's some more data. This is available on the Great Lakes Fishery Commission's webpage. You can find it at www.sealamprey.org and then dig through the menus and you can find the current status of sea lamprey populations. Looking at each one of these lakes, if you look carefully, there is a green line, a green horizontal straight line for each one of those lakes. That mark, it represents the 10% of historic highs level. And that is always our target each year for the control program. We want to maintain, or we work to maintain sea lamprey populations at or below 10% of their historic highs. And you can see that the sea lamprey populations, they bounce around. Some years we are meeting our target, some years we are below, other years the populations are high. Currently, we are above target for sea lamprey populations in Lake Superior as well as Lake Erie. We're below target or meeting the target in Lake Michigan and Lake Ontario. And Lake Huron, right now we're just slightly above target, but it's not by much. So across the Great Lakes, the program does a very good job of keeping sea lamprey populations, reducing sea lamprey populations to 10% of their historic highs, even though it does change every year. And when sea lamprey populations get a bit higher, we increase our effort at controlling sea lamprey populations to push them back down. One of the other great things about the Sea Lamprey Control Program is that it's highly responsive. It is adaptable to what the current status is in the Great Lakes. And I should also give right now, as I'm thinking of it, just a huge thank you to everyone involved in the Sea Lamprey Control Program, including people that work for the Fish and Wildlife Service and Fisheries and Oceans Canada. Those are the two agencies that have the people that are the boots on the ground, applying lampricides to streams, operating traps and checking on those barriers. Those are the organizations that conduct the work of sea lamprey control. That program is coordinated by the Great Lakes Fishery Commission, but that program is also in existence because of the support of people that live in the Great Lakes region, like everyone that would be seeing this video right now. So thank you to you for being supportive of sea lamprey control. And there are specific individuals, for example, that allow access to streams, to treat streams through their backyard in some cases. So none of this work can be done without the support of the public, and we really appreciate that. Some other fun things for where I work at Hammond Bay Biological Station. We just had a new laboratory built a few years ago. It's wonderful for assisting the work that we do at our station. So we're quite grateful to have this new facility to work in. Oops, you can see the group of people at our station. This picture is a few years old. I haven't been able to get a new photo for the past year because of the COVID-19 pandemic, but once we are all allowed to return to work again, I will certainly get a new photo of the current staff. But you can see it, it takes a village to find ways to control sea lamprey and restore healthy fish populations in the Great Lakes. We have a variety of people with a variety of skill sets that work at our station. And as I'm on this topic, I've focused today primarily on controlling sea lamprey. The other side of the work that's done at the Great Lakes Fishery Commission, as well as Hammond Bay Biological Station, is restoring native fish species to the Great Lakes. Ultimately, we are interested in controlling sea lamprey because we want to see healthy native fish populations and other fishery species thriving within the Great Lakes. So we know we are successful with our control program when we see valuable fisheries in the Great Lakes and healthy fish populations. And currently our fisheries in the Great Lakes are highly valuable. They are valued at over $7 billion, with a B, $7 billion each year. So, and sea lamprey control is a big part of that. I mentioned actually I didn't mention yet during my call, Hammond Bay Biological Station has traditionally been open for tours. Unfortunately, again, the pandemic has forced us to close the facility to the public, and the construction of the new laboratory has also forced us to close down the station to the public while that construction work has been ongoing. So we are not currently hosting tours at the station, but it will hopefully only be a few more years where we are back open to the public and back open in a bigger and better way. We have an interpretive entryway that is being planned that will have awesome interactive exhibits, all sorts of great information for youth and adults. We'll even have live tanks of live sea lamprey where visitors can get up close and personal with these invasive species and learn a lot more about sea lamprey as well as native fish species and other fishery species within the Great Lakes. So that is likely still a few years down the road, but keep your eyes out for advertisements in our local newspapers and our local visitor guides, because once we are open to the public again, we will begin advertising. So hopefully you have a chance to come and see us at Hammond Bay Biological Station. Finally, if you like what you've learned here or curious to know more about the Great Lakes and Great Lakes fisheries, check us out on social media. The Great Lakes Fishery Commission is on Facebook as well as Twitter. Our hashtag is @LampreyControl, but you can also find us by simply searching for Great Lakes Fishery Commission. And finally, thank you again for everything you do and for your interest in the Great Lakes, as well as Great Lakes invasive species, and for watching this presentation. And I will stay here if anybody has any questions. I am happy to take questions.
Bev, do you have any questions?
Oh, I was muted.
Okay.
No, I thought it was very, very interesting. I remember quite a few years ago when there was such a big fuss about the lamprey coming in from the Atlantic Ocean. I forget how many years ago that was. And you say it's 150 years that they've been coming in?
Yeah, for about 150 years
Yeah.
since they first started invading. Yeah, much of
I guess I wasn't there then.
But still by the 1920s and 30s, they were invading en masse, but the strongest effects on the environment and the economy were felt in the 1940s and the 1950s through even the 1960s. So yeah, there are lots of people that were alive at the time that are still here that would have experienced some of these effects firsthand if they lived along the shorelines.
Yeah, I can't remember what they were called, but when I was young, we used to go visit my grandfather in Portland, Oregon, and they were always talking about I thought it was the lamprey. They had the round mouth like that, along the rivers there. I guess it was even into the rivers there. But I don't know if that's the same thing.
Great that you pointed that out. Different species. So that would be Pacific lamprey. So if this was in Oregon,
okay.
that would be Pacific lamprey. That is another type of lamprey species. They're not sea lamprey though. Those Pacific lamprey are native to the Pacific Ocean and the tributaries to the Pacific, and they are actually valued there. So in the Pacific Ocean, as well as in the Atlantic Ocean where sea lamprey are native, these lamprey species are actually valuable. And in some places they are actually eaten as well. So they are themselves a fishery species that people are interested in catching and then selling for others to eat. And in some parts of the world, sea lamprey and other lamprey species are considered a delicacy. So people are willing to pay a lot of money to have a dinner of lamprey. That doesn't happen.
I would.
Go ahead.
I said, I don't think I would pay a lot. I wouldn't pay anything.
And in the Great Lakes, it's a good thing that people would not be interested in ever having a sea lamprey for dinner, because sea lamprey do carry a fairly high contaminant load relative to their body size. The amount of mercury in a sea lamprey is about the same as what one of our Pacific salmon species that have been introduced to the Great Lakes would carry. And it's just in a lot smaller package with the sea lamprey. And that is because many contaminants, such as mercury, do bioaccumulate through the food web. So those contaminants are most concentrated at the top predator fish. Mercury is concentrated within the blood. And so when sea lamprey are feeding on the blood of top predator fish, they're getting quite a heavy dose of mercury. So we would never actually want to eat a sea lamprey from the Great Lakes. And when sea lamprey first invaded, many folks did try to start fisheries for sea lamprey, commercial fisheries for them, but they never took off. It didn't seem to matter whether people baked the sea lamprey, fried them, boiled them, pan fried them. Nobody seemed to have the palate to enjoy sea lamprey. And ultimately that has been a good thing now that we are a lot more knowledgeable about contaminants. Yeah, and something that I just remembered I didn't do yet, this is a factor of doing a presentation over Zoom where I have my live sea lamprey hidden in a cooler and not in a tank alongside me like I would do in person. I have to pull out those live sea lamprey that I mentioned earlier. So that would be a very disappointing end to my presentation if I forgot to pull out the live ones. So I will get some of my critters out now. So I put on gloves, if you notice me doing that. Sea lamprey are extremely slimy. They are very hard to hold with bare hands because they're just that slippery, but wearing a simple cotton glove provides a lot more grip. And it's also beneficial to the sea lamprey that I have for outreach, where I need these sea lamprey to survive for a variety of outreach events. So I actually have to show some care with how I handle these sea lamprey.
Would they grab onto your hand?
It can, and I will show you that. I am glad you asked. So here is a live sea lamprey. This one is about your typical adult size of about 18 inches, maybe slightly longer. You can see how they can basically twist their body in just about any shape they want to twist it into. I've even seen a sea lamprey turn its body into a knot. And that was when one sea lamprey attached to another sea lamprey in the tank and began feeding off of the sea lamprey. The lamprey that had been attached to turned its body into a knot, ran its tail down the length of its body, and knocked off the sea lamprey that was attached to it. Now, sea lamprey don't typically feed on other sea lamprey in the wild. They're solitary individuals. They are not typically clustered with other sea lamprey. So we don't think that happens in the wild, but in our tanks where we keep sea lamprey at higher abundance at Hammond Bay Biological Station, that does happen sometimes. But you can see right
that's darker. That's darker than the one you have on the photo here.
It is, there is some variation in color for the sea lamprey. Yep, some of it's just the lighting in my office. I don't have great lighting in here to actually shine well on the sea lamprey. But yes, they do have variation in color. Some sea lamprey look a little bit more orange in their adult stage. Most are this kind of brownish color. And you can see how it's actually trying to suction on right now to me. But it's not able to suction because I'm wearing the glove. But if I take that glove off, you'll see that sea lamprey was capable of suctioning on very quickly. It's basically an instantaneous suction. But I am not worried right now because all this sea lamprey is doing is attaching to my hand, suctioning on. It is not trying to rip a hole through my hand. The sea lamprey is aware that I am not a fish. I am warm-blooded. It would not like the taste of my blood. It knows that. It can probably smell that I'm not a fish as well. So all it is doing is suctioning on. It is not trying to feed right now. Now
How long can they survive out of the water?
Actually, I was just going to say that. Great question. Good timing. They can stay out of the water easily for a minute or two with no detrimental effects on them, as long as their gills stay moist, which I'll show you more of those in a second. As long as their gills stay moist, sea lamprey are able to extract oxygen right from the air. So I can safely keep my sea lamprey out of the water for a minute or two, and then I return them to the water, and I'll grab out a fresh one now. Here is one of the more petite sea lamprey in the Great Lakes. I'll actually let this one suction onto me as well. One of the other fascinating things is that sea lamprey actually calm down once they have attached to something. So it's actually much easier to handle a sea lamprey once they have attached. So this is a thinner, shorter sea lamprey than the one I was just holding, all part of the natural variation in their size. Something that's really important for me to mention is that you never have to worry about a sea lamprey attaching to you if you're out swimming in one of the Great Lakes or in one of the Great Lakes tributaries. Sea lamprey do not attack people. Like I just mentioned, they can tell the difference between humans and fish. They know we are warm-blooded organisms. They can likely smell that we are not fish, and they have no interest in attaching to us. So you can swim without fear in the Great Lakes. A sea lamprey will not attack you. The only reason the sea lamprey is suction onto me right now is because I stuck my hand in front of its face. The same thing would happen if I take, for example, my cell phone and put it in front of the sea lamprey's face. Ta-da! That sea lamprey will suction onto any flat surface that is presented to them. It's not doing it because it's trying to attack my cell phone or attack my hand. So there you can
Doesn't
see
have
just
eyes,
how
it just has smell.
it has eyes, and I'll get this one back in the tank now. It does have eyes, but we think the eyesight is inferior to its sense of smell. So most of the sea lamprey's decisions are being based on what they can smell, but they do use their eyesight for certain things, such as we suspect choosing a mate, or excuse me, choosing a fish to attach to. Likely a sea lamprey will sniff out its fish host in a lake, but once it's close enough to actually see the fish, the lamprey likely will orient where it wants to attach to that fish based on what it can see. It's actually really difficult to study sea lamprey when they're in that parasitic life stage out in a Great Lake, because it's hard to find them. Most of this is happening at the bottom of the lake as well. Sea lamprey lack swim bladders, so they usually sink down to the bottom of the lake, and their preferred host species, such as lake trout, also live in the bottom of the lake as well. And so this is happening in an area where it's really tricky to conduct research. But there are some experiments that are planned to try and figure out just how it is that sea lamprey are able to find and eventually attach to different fish species. Something else that I should mention that I usually mention earlier on in my presentation is that sea lamprey do attack a variety of fish species. I've mentioned lake trout multiple times, but it's not just lake trout that sea lamprey attack in the Great Lakes. They will also attach to whitefish, the introduced Pacific salmon species, walleye, cisco, and even smaller fish like yellow perch will be attacked by sea lamprey, and some of our largest, most majestic fish like lake sturgeon will also be attacked and can die due to sea lamprey attaching to them. But it has been lake trout that has been their preferred prey species, with lake whitefish as the second most preferred prey species. Yeah, but they are a fascinating creature. They are the subject of a lot of study within the Great Lakes as well as other places across the world. And lamprey species are studied beyond just sea lamprey. Other species are studied worldwide. And it's a pretty fascinating species to be able to work with. Any other questions?
No?
Thank you. It's been very interesting.
Good. Well, thank you. Well, I will stop sharing my screen at this point.
Okay.
And so it's now back to me. Well, thank you so much for this opportunity to talk about sea lamprey and Great Lakes fisheries. I really appreciated the time today.
And thank you. It was really interesting. I'm glad we went ahead and did it because Beverly signed in late. But
Yeah,
at least she got to hear part of it. So
I had a meeting this morning with Rogers City. Team Rogers City, are you familiar with that?
no.
Oh, okay. I had a Zoom meeting, but they meet and everybody, they usually have about 30 some people on the meeting for development and other interesting features, tourism around the area, and it's all in a positive mode.
Oh, great. What was the name of the organization again in Rogers City?
Team RC. Scott McLennan, the mayor of Rogers City, hosts it, and he says he wants only people with positive ideas on the to join, and everybody tells what they're doing. We learned about the new owners of Knabe's apple farm there, and you learn about what people are doing. They do a lot of sharing, and then they have a special speaker there too. you might want to see if you could get on there, because you'd have a great audience there.
Yes, thank you, Team RC. I will keep that in
Yeah.
mind. That would be fantastic. That is
Scott
a great
McLennan,
person to
the
talk to.
mayor.
Okay,
If you contact Scott McLennan, the mayor.
beautiful idea. Thank you.
Yeah.
Yeah, that's great. Thank you
You're
for that
welcome.
suggestion.
Okay.
All right, so again, we'd just like to thank you for giving us such information that is just astounding. So
Thank
can't
you.
wait to see it on YouTube so I can share it with my granddaughter.
Oh, beautiful. That's wonderful. Thank you so
Yeah.
much. All right. Well, have a great
All right.
day, everyone.
You
Okay,
too.
goodbye.
Thank you.
Goodbye.
Bye.
Bye-bye.